Artificial intelligence isn't just changing how we work, it's changing how much power the world consumes. Behind every AI model, every chatbot, and every automated system, there are massive data centers working around the clock. And as these systems grow more powerful, so does the demand for energy. The real question is no longer just how to process data, but how to manage the power required to do it. At their core, data centers are complex ecosystems. They rely on networks of servers working together to store, process, and deliver data across the globe. Supporting that operation requires far more than just computing hardware. Cooling systems, ventilation, backup generators, uninterruptible power supplies, and network infrastructure all work together to keep everything running smoothly. And as AI continues to push computational limits, these systems are consuming more power than ever before. In fact, data center energy usage has grown rapidly in recent years, becoming one of the most significant operational costs for organizations worldwide. But power isn't just about cost, it's about reliability. Without accurate monitoring, even small inefficiencies can lead to overheating, system failures, or unexpected downtime. For operators, maintaining uptime is critical, and that starts with understanding exactly how power is being used at any given moment. That's where the challenge begins. AI systems are often described as black boxes. You can see what goes in and you can see what comes out, but what happens in between isn't always clear. This makes predicting energy usage incredibly difficult. Traditional methods that rely on analyzing data after it's collected simply can't keep up with these dynamic, unpredictable workloads. To manage modern data centers, engineers need real-time insight, not delayed analysis. This is where National Instruments takes a different approach. Instead of relying on rigid, fixed systems, NI uses a modular platform built around flexibility and real-time performance. At the center of this approach is CompactRIO, a system that combines real-time processing, sensor-specific inputs, and a tightly integrated software environment. Rather than just collecting data, this system allows engineers to observe and respond to power behavior as it happens. In one example configuration, the system uses a CompactRIO controller as the central processing unit. Voltage is measured directly across power phases, while current is captured through connected sensors. Together, these measurements provide a complete, synchronized view of how power is flowing through the system. On the software side, tools like LabVIEW Real-Time and the Electrical Power Toolkit bring everything together. Engineers can filter signals, analyze frequency ranges, visualize raw waveforms, and calculate power metrics, all in real time. The result is a system that doesn't just record data, it transforms it into actionable insight instantly. As AI continues to evolve, the demands on data centers will only increase. But with modular systems like this, power monitoring can shift from reactive troubleshooting to predictive control. Instead of waiting for something to go wrong, engineers can identify patterns, detect anomalies early, and optimize performance before issues arise. This concludes today's video. Thanks for watching. If you're looking for legacy NI parts, calibration services, or more technical resources, head on over to apexwaves.com to get what you need fast. We have thousands of NI parts in stock and ready to ship, including legacy and obsolete modules you won't find anywhere else. And if you found this helpful, don't forget to like this video and subscribe to our channel for more product highlights, how-tos, and industry insights.